Other analysis techniques. This is Chapter 9, Part 1. Following are the learning outcomes. After going through this presentation, students would be able to perform calculations involving engineering economic problems associated with future worth and with benefit cost ratio. These are the two topics, particularly benefit cost ratio, we have to be extremely careful about. We'll be able to use spreadsheet to carry out one or more of these aforementioned analysis. And later on, we'll do the same thing with payback period, sensitivity analysis. So, future worth analysis. In order to use the future worth analysis, there's a function called the future value function in Excel, and we will demonstrate the utilization of that. So here's an example. Suppose we stop spending our daily dollars in Starbucks, which we were spending $5 a day for 2 lattes. We did this for 45 years, 365 days a year, and the rate of return is 5%. If we instead saved it at this 5% rate and we compound quarterly, so it's not daily compounding, it's quarterly compounding for 45 years, we had to find out how much would we have saved if we'd not had this coffee every day. So to do that, we will go to this problem. Alt V Z0. Alright, so let's just do it here. Equals FV. The rate is 5%. Whoa, wait, it has to be compounded quarterly, so we have to consider quarters. And the number of periods, now there will be 45 years times 4 quarters. Oopsies. 4 quarters. The payment per quarter, now that's where the trick comes in. The payment per quarter, and we should make it negative because the future value then will be positive. $5 per day times 365 days per year divided by 4. And so we have to make sure that the rate is quarterly, the number of periods are quarters, so 45 times 4. The payment is also per quarter. The present value, we have nothing today, and we consider the end of the period consideration. So shift control 1, 305,006.21. That's how much we'll have saved up by the end of 45 years. Okay, so future value is equivalent to present value, and the reason for that is, let's look at 2 projects. So 2 projects, Alt V Z0, enter. These are the 2 projects. The cost is 300. The maintenance cost, so there is a setup cost, initial setup cost. The maintenance cost per year is 20 and 15 respectively. Again, that's negative because of cash flow association. Should make that negative, but it's okay, we'll keep that. Lifetime of each project is 10 years, and the rate of discounting is 5%, or the MARR is 5%. The present worth is PV of rate 5%, K6, number of periods, it's all annual. The payment is K5, or it is a positive number. So the PV of a positive number would be negative. And the future value is 0. That is, in the end, we have no cash flows, and the type is 0. And since the PV will be a negative number, our 300 is already a negative number, so we just add them literally. That gives us a complete negative number. Now, if we'd wanted a positive present worth, all we would have done is made the payment negative and the present value negative as well. So positive. Control R, Control R. Now, there are 2 ways in which we can find out the equivalent uniform annual cost. And the first is fairly straightforward. Just take the PMT of this, rate, comma, the number of periods, comma, the present value. Since this has become negative, positive, we have to take the negative of that positive, so that the answer is negative. The future value is 0, and the type is 0. So $58.85 and $34. Just Control R will do it for us, because everything moves in a relative frame of reference. The other one is just take the present or the PMT of a rate, comma, the number of periods, comma, the present value. We just take the $300. So it's going to give me a positive PMT because I'm considering the present value as negative. So all I'll do is I'll just add the maintenance cost per year to this, and shift control 1, alt O, C, W, control Y, control R. So same answer. Now future value can be found out using three methods. The FV function on all of them, but the FV function can be imposed on the present value or the payment or on both the initial cost and the lifetime. So we'll just do the most tricky one. Equals FV, the rate, comma, the number of periods, comma, the payment. Now we have to be careful. If we use a positive payment, then the future value will be negative. So we will use a negative value of the maintenance cost, and the present value is already negative, so the future value of that will be positive. So that, and then 0. Enter 740.23 and 433.00. So that is how we find out the future worth of a project. Notice two things. We can find out present worth, payments, or the EUAC, or the future value with multiple ways, at least 3 different ways. The second thing we got to notice is as the present worth goes down, the payments in absolute value, the payments go down in absolute value, and the future value also goes down in absolute value. So they are directly proportional to each other. All these are negative, by the way, because they're all cash losses. All right. Let's do the present worth analysis with respect to the benefit cost analysis. So present worth analysis may or may not produce the same result as the benefit cost analysis. So, but we're going to consider that next. So let's assume we have two devices, A and B. A has a lower setup cost, and we have done this before. We have done this in chapter 5, some example. I forget the exact example number. I think it should be here in the Excel. It is not. That is my example. All right. So Alt VZ0, enter. So we have two devices. A gives constant cash flow or savings. B has variable. So it's growing by 20%. The savings are growing by 20%. And we've already found out the net present worth using the NPV function. We can also find out the IRR. So the net present worth and the IRR are not directly proportional to each other. The project with a lower net present worth actually has a higher IRR. That's just because of the initial setup cost. Now, can we do a benefit cost analysis? Yes, we can. The first step is to find out the present value of benefits. So equals PV parenthesis rate. The rate is right up there, comma, the number of periods is 5. We should fix this cell. So $H9, $H9, comma, the payment minus of 60. Well, we should just use the NPV to find out the present value of the positive cash flow. So equals NPV, straightforward, isn't it? 4%, and then all of these things. So it's going to give me a positive answer. NPV of benefits, and control R, NPV of project B. All right, now the present worth of the cost, that's just the initial setup cost. So that's 200 and 350 respectively. And we're just trying to say it's cost. So yeah, negative cash flow, but we understand that. Control R. Okay, now the benefit to cost ratio is this divided by this, and then control R. Shift control 1. So obviously project A ekes out 0.03 basis points extra as compared to project B. But more importantly, we have to perform an incremental analysis. Now, incremental analysis does not mean that what we do is kind of like in the previous chapter for IRR. So what we do is take the difference of the benefits, the higher minus lower, and then take the difference of the costs, again the higher minus lower, and take their ratio, 1.27. Now, is this 1.27 greater than 1? If yes, then do the greater cost project. Just like before. Okay, so that's how we do it. Next, we have to be careful with BC analysis. So for example, in this particular case, we have two machines, X and Y. Initial cost of X is 200. The uniform annual benefits from X is 95. The savage value is 50. Now the savage value, one might be tempted to add it as a benefit. It's actually just a lower cost. So that's a way, and different cash flows have different interpretations. Sometimes the same cash flow can be categorized into multiple interpretations. So that's why we have to be careful with BC analysis. The useful life of machine X is 6, useful life of machine Y is 12. So here is a table. We lay out all the cash flows. Notice how we have put the costs here, and since machine X needs to be replaced after 6 years, we have to add that cost. So the $50 salvage value minus the $200 new machine cost. That's the 150. So notice what we've done. We put the salvage value as a cost, just a negative cost or a positive benefit. Not a benefit, sorry. The word benefit does not exist in this cost column. Similarly, X is benefits, and the only benefits we see are the cash flows from the uniform annual benefits, $95. The present value of that, is it 95? That's very curious. I am curious about that. That's a very... Alright, here we go. So let's find out. What is a function? Yep, PMT. Oh, we found out the PMT, the PM. Oh, okay. So what we've done here is we've taken the PMT approach instead of the PV approach or the PW approach. That's fine too. So we have taken the EUAB minus EUAB of each project. So EUAB of Y, equivalent uniform annual benefit from Y, minus equivalent uniform annual benefit from X, divided by, so 120 minus 95 right here. 120 minus 95 is minus G17 plus I17. So 120 minus 95 is 25. Similarly, 95.72 minus 39.44 is 56 point something, 0.28. Right. So that's the change EUAC of Y minus EUAC of X. And the ratio of the changes in EUAB divided by EUAC will give us this ratio, 0.44. Delta B over delta C. Change in benefit Y over X divided by change in cost Y over X. And this is less than 1. So therefore, we will drop. We will not consider the more expensive option. We'll only consider the cheaper cost option in this case. And the BC analysis kind of points to that, but it does not need to be set in stone. So the BC for X is greater than BC for Y, but we cannot interpret that. We have to do the incremental analysis. So even though the project Y's BC analysis suggests it's more than 1, we cannot go for it. We have to go for the X based on this incremental analysis. All right. So the next one. So X is lower cost, but still better. Y has higher cost and has BC equal B to C ratio greater than 1, but still not chosen. That's really curious. All right. Now, how do you select the best project based on benefit cost analysis from multiple projects? So what we do is, first of all, we reject all the projects whose BC ratio is less than 1. So let's assume, and then we start from the lower cost and then do the incremental analysis either of EUAB to EUAC or PW of B, change in PW of B to change in PW of C. So either way, there are two methods of that. Now here we have A, B, C, D, E, F from the previous presentation, and we reject A, C, D, and F because their BC value ratios are less than 1. So we have only B and E left, and we'll perform the incremental analysis of B over E because B is higher cost. So when we compare B over E, the change in benefits E over B are $5,000. So present value of benefits E over B. So 25,481 minus 2462 will be $5,000 plus dollars. Yeah. And then the cost, change in cost of E over B. So we're not doing the EUAB and EUAC. We're actually taking the present worths. So 25,000 minus 19,500 is 5,500. So ratio of change in benefits to change in cost is 5,000 divided by 5,500, 0.91, less than 1. Reject the higher cost, that is B. Higher cost option, B is rejected, and we select higher cost, lower cost option, that is E. Lower cost, higher cost, where does that come from? Look at this number. This is higher cost, and this is lower cost. So we select E. Moving on, we have two projects with unequal costs now, and they have maintenance costs and disbenefits due to the initial construction. So the keyword is disbenefit. Now, where does the disbenefit lie? Is it a benefit or is it a cost? Well, disbenefit by definition therefore becomes a lack of benefit or negative benefit. So we include that with that. Sometimes maintenance cost can be included with benefits. Sometimes maintenance cost is included with cost. So again, we have to be careful. Now in this particular case, we include the, let's see, what have we done? Have we included the maintenance cost in the cost? Let's go back to our Excel spreadsheet. So here we are. Nope, too far. Yes, this is the example. Alt V Z 0, enter. And so present worth of benefits. We have included the disbenefit. So let's just calculate it. Equals PV rate is 10%, and I'll fix so $B9, because we'll do it for both, comma. The number of periods, $B8, $B8, comma. The payment. First of all, the annual benefit is, and I use the minus sign because I want a plus in answer. The disbenefit. The disbenefit is 900. Now, is it annual or is it monthly? Let's assume it's, is it annual or is it one time? If it's an annual disbenefit, then all we do is just add that to the 1600. If it's a one-time disbenefit, it's going to be initial then. And then so we will get a positive PV for the negative annual benefit cash flows, and therefore we'll subtract the disbenefit from that. So 0, 0. I'm just going to consider it to be one time for now. Let's see. The disbenefit is one time. Yeah, it is one time. 11,269. And then just do a Control R. Alt OCA. Yep, it worked. Now let's do it for cost. So equals PV. The rate is $B9, comma. The number of periods $B8. Sometimes it's just easier to type it off. Annual maintenance is 150. So B5. Excellent. Comma. Future value 0. No last cash flows. Type 0. And then it's going to give me a negative value. Minus 8,900. So all negative, shift control 1. All OCW. Control Y. Alright, and we can always put a negative sign on top of this, so minus of this, plus of, or we could put a negative sign anywhere we like. We can make the payment negative in order to get a positive answer, and we can make that positive. So boom, same answer. Control R. No, that did not work. Why did that not work? Annual maintenance, plus 8,900. I'm so funny. Why would I put an 8,900 there? Plus, it will be B4. Alright, there we go, more accurate. Now, what do? How do you calculate the incremental BC analysis? It's not these two, these are both more than one. So equals change in the benefits. Change in benefits is 14 minus 11, the higher cost minus the lower cost, divided by parenthesis 13 minus 10. Change, again it's change, incremental analysis, less than 1, okay, reject the higher cost 1 or the lower cost 1. Now, somebody might come up and say, hey, wait, you just took this annual maintenance cost too high. It is not 225. Economies of scale 210. Look, well, this is sensitivity analysis. What I'm doing is I'm just trying to figure out Alt AWG to a value of 1. What is the minimum cost or the maximum cost I can pay in order to do project 2? So GoalSeek tells us maximum cost would be 197.67 in order to adopt project or become neutral in project 1 versus project 2. If it was 196, we will adopt project, marginally adopt, because this is, if you make it 4 decimals, it's going to be more than 1. So 1, 2, 3, 4, boom, more than 1. And so if you make it a little less than that, 190, then you'll see a clear cut advantage of project 2 or 1. Anyway, so this is called what if analysis or scenario analysis, which we will be studying in part 2 of this particular presentation. So that's the incremental analysis. Notes, disbenefits here were considered as negative benefits, not costs. Again, that's open to interpretation. Annual maintenance is not a cost here. It's a cost here, but not negative benefits. So again, open to interpretations. And therefore, considering all these assumptions, the smaller option is better. Finally, let's do again an incremental BC analysis. Now we have two widgets, A and B. B clearly, look at that, costs more. Annual maintenance 225. Material moving cost, so its initial setup cost 900, 2100. Annual savings 1600, 2200. Now what they've done in this, going back to the Excel, Alt V Z 0 enter, is this. So equals PV or PW, right, but PV really, rate 10%, actually it should be $B4, comma $B3, the number of periods. What are we doing? Benefits. So minus of annual savings 1600, future value, nothing in the end, comma type. And so we are thinking, what about the annual maintenance? Should we include that or should we not? Look, clearly the value does not match. So what's wrong? So what they've done in this example is just added the maintenance cost, give the answer, boom. This is the book solved example 7, shift control 1, 15022, and the present worth of cost is, well, you don't have to do anything, just add the two numbers, 8900 plus the one-time moving cost 9800, control R 14,000. The BC analysis will give you that, but what we do is incremental analysis. So benefit larger project minus the smaller project divided by cost of larger project minus the cost of smaller project. 0.95 less than 1, reject the larger cost project, that is widget B, and select the widget A. Now goal seek will tell us what is the base value. Set this to value 1 by changing the annual maintenance again. Boom. Oh, cell must contain a value. Why is it not containing a value? Oh, it is a formula linked with that. Okay, so we can disengage that formula and say, okay, so what is happening is this is incrementally adding something to the cost with widget A. Widget B is just an enhanced improvement on widget A. Alt AWG to value 1. Can we even achieve that? Let's see. Yes, we can actually. Anything less than 47.8 will actually make widget B superior to widget A in adoption. So if we make it, for example, 40, boom, we are more than 1. We can do it. This is called scenario analysis once again. So notes, annual maintenance now goes into net benefits. So we have to be really careful. Material moving cost is one time, so it's included with the cost and its initial setup costs. Lower cost option based on these assumptions is better. Again, notice what we're saying is this can be wobbly depending on what assumptions you make. To summarize, future value and benefit cost analysis provide another way to compare two projects besides the present worth and the PMT, the EUAC, EUAB approach. Future value is useful, or future worth is useful if we need to perform a repercussion analysis. What if the action of this, what is the action of this on my cash flow after 10 years? The BC analysis is extremely useful again in weighing multiple options, just like IRR or NPW approach. When neither input nor output are fixed, incremental analysis is what we do. Similar to the rate of return analysis, except here we reject projects with BC less than 1. That's chapter 9 part 1. Thank you very much for listening.